Hello, everyone. We're going to go ahead and go over section 3.3, which is going to be about dividing polynomials. So we've looked at polynomials already in more of a graphical sense in sections 3.1 and 3.2. So now we're going to look into polynomials a little bit more algebraically and what we can do with them more on the algebraic side. So one thing that we can also work with is things like factoring a polynomial, and this is going to be something that's key in dividing polynomials, which is what our section is going to be all about for 3.3. So we're going to take polynomials, divide them, find their dividends and their remainders. So we're finding the results of when we divide polynomials here. And we have a little bit of an image here, so an idea behind, things like polynomials. You can factor them, or even just divide in general, and you'll be left over with certain things. So if you say, you're going to divide pizza by cheese. Pizza can be separated into a bunch of different things. It can be separated into cheese, and let's say it's pepperoni, so it'd be like cheese and pepperoni and tomato and pizza dough, and you're dividing this all by cheese. And for a problem like this, it does work out very nicely, because in something like this, if you had, cheese times pepperoni times tomato times dough divided by cheese, you get to cancel out the cheese. You can cancel out those two things, and what's left over is the pepperoni, the tomato, and the dough. So just an idea of a reminder kind of what we do when we divide and things like that. That's going to be the same idea with polynomials. We'll have a very large polynomial divided by a smaller polynomial. And maybe the larger polynomial can be separated into a few different terms here. And maybe the smaller one, maybe it can, maybe it can't. But either way, when we divide, we have whatever was left over after that division there. All right. Let's go ahead and get into math and definitions part and less of the pizza analogies. So long division of polynomials. If you remember long division from probably elementary school, may not have great memories of it. We're going to do with polynomials. So we've got long division of polynomials. So this is dividing that's going to take a lot of steps. It's going to be extremely similar to the long division that you probably learned at some point in your life, except we now have things like x's and exponents and things like that. So it's going to be a little bit different, but the process remains the same. So beginning off our division algorithm, we say if p of x and d of x are polynomials and d of x is not equal to 0, then there exist the unique polynomials q of x and r of x, where r of x has to be 0 or of some degree less than the degree of d of x, such that we can write our answer in two different forms. So what we just said here is that you have some polynomial p of x that is being divided by the polynomial d of x. Since d of x is the denominator, if you were to set it up like a fraction, it cannot be equal to 0 just because we can't divide anything by 0, so we just have to state that to be clear. And then when we actually divide this, we would get the results of q of x and r of x. Q of x is the quotient. It's basically the whole that came out of that division. So it was whatever that came out whole, and then r of x is your remainder. So your remainder is 0, meaning that it evenly divided, you just have the quotient, or you have your remainder, which is probably going to be some expression or polynomial, and it just has to be of degree less than d of x, the original denominator. So remember, degree is highest numbered exponent on x. So if your divisor, which is d of x, that's with the denominator in fraction form, if that is degree 2, like x squared, then your remainder has to be less than that. It's going to be just a number, or it's going to have x to the power of 1. So it has to be of degree less. And you'll kind of see how we get to this point when we do some problems, because your remainder is some portion, something smaller out of your original divisor. It means that you can't divide anymore. So that's the idea there. And what these two things here are just the two different ways that we would write our answers. So that's what these two statements are right here. They are the two forms of the division algorithm, and it means that when you have solved your problem, you would write your answer in one of these two formats. So the first one being more of the fractional form, we see p of x divided by d of x. So we're going to call that the dividend. It's the polynomial that is being divided. So our dividend divided by the divisor, d of x, is the polynomial that is doing the dividing. It's the denominator. And this would be equal to the quotient, or the whole polynomial that can be divided out of p of x by d of x, so out of your dividend by the divisor, plus your remainder, the terms that were left over that had to be of degree less than your divisor, your remainder divided by the divisor. So we have to have all of these things together in our answer when we kind of formulate that final answer there. That is one form of the division algorithm. The other form is this longer one. We don't see any more fractions in this case. We do write them just all out. So we have p of x, which is the dividend, which is equal to d of x, the divisor, times the quotient, plus the remainder. So we have two forms of the division algorithm. And in your homework, you'll be asked to write an answer in either one of these forms. This will be indicated because in the homework, it will say p of x divided by d of x equals, and then there'll be that big box where you actually put your answer. So that would indicate this form of the division algorithm, this kind of fractional one here. If it wants the other form, it would say p of x equals, and then you'd have the big box where you put your answers, and that indicates that you need to use this form instead. So it will indicate which one you need by writing out either p of x divided by d of x equals, or just p of x equals. And it will indicate which one of these forms that you'll need to use for that answer. All right, so we went through all the vocab, we went through the two forms of the division algorithm, which, as a reminder, just to reiterate, it's just the way you're going to write the answer. This is not how to do it or how to divide polynomials, it's just how you're going to write the answer, and all the vocab included. So, all right. This is how we actually do polynomial long division. So polynomial long division, we have 4 steps here. Step number 1 is that you need to set up the long division problem. You would write out your dividend, the one being divided, with a horizontal line above it and a vertical line to the left of it. So we see that we have a little example here. If we have 2x to the power of 3 minus 7x squared plus 0x plus 5, if you have that as your dividend, you would draw the line above it, above the whole term, and one to the left. You can make it, a little curvy like this one here. You can just write straight down, up to you. This is what we're going to call the house. So if you ever hear us say the house, that's what we're talking about. So we can call it the house. Then we write out our divisor to the left of that one small vertical line. So our divisor in this case would be x minus 3. So we wrote what is doing the dividing, house, and then what is being divided goes under the house. Then if there are any missing terms in your dividend or in your divisor, you would write a 0x to the power of n, so whatever term that it was that was missing. So in our case, in our dividend, we actually have a 0x. We've got 2x to the power of 3 minus 7x squared plus 0x plus 5. This means that our dividend was probably originally given to us as 2x to the power of 3 minus 7x squared plus 5. So it kind of skipped over that single x term. So if that ever happens, you would just end up writing a plus 0x to whatever exponent that you need for that spot. And so you just fill that in. We fill it in as a placeholder to indicate that there really isn't anything there, but it will keep our work a lot more clear when we do that. It's not entirely necessary, but it will make it confusing if you don't have it. So, all right, step 1 is just to set up the problem. That's how we set it up. Step 2, we can divide the leading term of the dividend by the leading term of the divisor. So the leading term, remember, is the first term in your polynomial, or it is the term with the highest numbered exponent. So in this case, for us, we have x minus 3. This is the divisor. The leading term would just be x, because it's x to the power of 1. It's the highest numbered exponent for the divisor. In the dividend, our leading term would be 2x to the power of 3, because that's the term with the highest exponent on x. And this includes the coefficient. So you would divide the leading term of your dividend by the leading term of the divisor. This results in the first term of the quotient of your answer. And you'll write that above the house. You can write it really anywhere above the house that you would like. Typically, we kind of write it beneath the second term in the dividend on top, but you could write it, more to the left, more to the right, whatever you want. But you would write that value then above your house. So once you've done that, you would multiply your divisor by that leading term of the quotient. And then you would subtract that result from the dividend. In this case, this automatically cancels that very first term of your dividend, which is the goal. You want to cancel the very first term. So that would cancel the very first term. Then you would subtract that result from the rest of those terms. You would have some new result, which we can call the new dividend. You carry down the next term from the original. You have a new dividend, and you restart the process. So step 4, you repeat until the new dividend has a lower degree than the divisor. So remember, degree, highest numbered exponent on x. So your new dividend, if it has a lower degree than the divisor, you are done, and that is the remainder. If it has the same degree or is higher, you need to keep repeating the process until you have a new dividend whose degree is lower than the divisor. And then that means you're done. So, all right, that was a lot of steps that was all verbally told to you. Let's go ahead and do an example and show really how this works. So for example 1, we're going to divide 8x to the power of 4 plus 6x squared minus 3x plus 1 by 2x squared minus x plus 2. Then we're going to express our results in each of the two forms of the division algorithm. So, all right, let's go ahead and go over to our notes so we can work on this problem. All right, so here we have our example. We're going to divide x to the power of 4 plus 6x squared minus 3x plus 1 by 2x squared minus x plus 2. So the first thing, step 1, is that we want to set up our actual problem. So when we want to do this, we want to verify something first before we just go ahead and start writing everything. We want to check and make sure and see if we have any missing terms. Which, if we look at our problem here, if we look at the divisor first, which this one is our divisor, this is d of x, or the divisor. And then we also have right here, this is our p of x, or our dividend. So we have p of x, or the dividend, and then we have d of x, or the divisor. We want to make sure if there's any missing terms. If we look at the divisor, we don't have any. We have 2x squared minus x plus 2. So we see that we start off with x squared, next term is an x to the power of 1, and then we just end off with a constant or an x to the power of 0. So the divisor is good. But if we look to the dividend, we see we have 8x to the power of 4 plus 6x squared minus 3x plus 1, and we skipped over x to the power of 3. So we skipped x to the power of 3. This means we're going to fill in that term when we write it in our format for long division. So, all right, let's go ahead and set up the problem then. With long division, you're going to have your house. So you have one horizontal line that's usually going to be pretty long, and then you have a little vertical line to the left of your horizontal line. This is our house. And we're going to write, remember, the dividend under the house. So we've got 8x to the power of 4 We skipped over that x to the power of 3 term, so we're going to write a plus 0 x to the power of 3. And then we can write the rest normally. So we're going to have plus 6x squared minus 3x plus 1. There we go. So our dividend is under the house. And then we're going to write our divisor outside of the house to the left. So our divisor is out here, 2x squared minus x plus 2. And that's how we'll have our setup. That was step 1. So we want to set up the actual problem. All right. So now what we want to do with step 2 is that you're going to take the leading terms of your dividend and your divisor and you'll divide them. So you'll take the leading term of the dividend and divide it by the leading term of the divisor. So we'll write that just kind of off to the side. So we have, in our case, 8x to the power of 4 divided by 2x squared. And we're going to divide these. This is in step 2. There we go. So we can label it. All right, so we're going to divide these terms. 8 divided by 2 is going to be 4. And then we have x to the power of 4 divided by x to the power of 2. As a quick note, anytime you have your terms being divided, let's say x to the power of a divided by x to the power of b, this would end up looking like x to the power of a minus b. So you subtract the exponents, you subtract the bottom from the top. So in our case, we would have x to the power of 4 minus 2, and 4 minus 2 is 2. So our result from this was 4x squared. That is the leading term of our coefficient. So we're going to go ahead and write that out. Coefficient, our quotient, wrong word, was our quotient. So we're going to write that value on the top, and we're going to write it right here, 4x squared. See how we took this value and we put it right there. So that is step 2. You take the leading coefficient of the dividend divided by the leading coefficient of the divisor. You take that result, you put it on top of the house. That is the next or the first term of your quotient. So that's all step 2. So now we're going to continue on here. We're going to erase just a few things. There we go. Erase that line. All right. So now what we're going to do is that you want to take that term that you just wrote above the house and you're going to multiply that term to each of the terms in the divisor. So we're going to go ahead and we're going to multiply 4x squared to each one of these values. Then you're going to take all of those answers and write them below and subtract them. So let me shorten up that line just a little bit, give us a little bit more room. So we're going to subtract all of those values. So all right, starting off with 4x squared times, and we'll write multiply right here, multiply. 4x squared times 2x to the power of 2. 4 times 2 is 8. And x to the power of 2 times x to the power of 2 means that you would add those exponents. So another little note up here, x to the power of a times x to the power of b would be x to the power of a plus b. So since we're multiplying these together, we add the exponents. 2 plus 2 is 4. So we get 8x to the power of 4. That means that we've done the right thing. We see that when we subtract these terms, the first terms are going to cancel. That means it's correct. All right, so the next one, we have 4x squared times negative x. So 4 times what's really just a -1 would be -4. So we're going to write -4. X and then we have x squared times x squared times x to the power of 1. We add 2 and 1 together to get x to the power of 3. So this would be minus 4x to the power of 3. All right, then that last term there, we've got 4x squared times positive 2. 4 times 2 is 8. The x squared gets to tag along. So we've got a plus 8x squared. So this step right here means you will subtract the result. There we go. So here we go. We have taken the first term of our quotient, multiplied it by each term in our divisor, and we have now written out the step to subtract from the result. So let's go ahead and subtract. So 8x to the power of 4 minus 8x to the power of 4 cancels. That was what we wanted. That meant that we were on the right track. Then we have 0x to the power of 3 minus negative 4x to the power of 3. So remember, you are subtracting. So if you're subtracting the whole statement, and then inside your statement you have another subtraction or a negative sign, that's going to be double negative. We have 0x to the power of 3 minus negative 4x to the power of 3. So that's going to become plus. So 0x to the power of 3 plus 4x to the power of 3, which ends up being 4x to the power of 3. All right, then the next term, 6x squared minus 8x squared. So since 8 was positive, we are just subtracting. So 6x squared minus 8x squared, 6 minus 8 is going to be a negative 2. And the x squared sticks along. So there we go. We subtracted, we canceled out the first terms, we got these results, and now we're going to bring down the next term. The next term being negative 3x. So you bring down the next term. This term right here is the new dividend. Since this is the new dividend, this means we are at step 4. We want to check, is the degree of the new dividend less than the degree of the divisor? The degree of the divisor is 2, since we have x to the power of 2. And the new dividend has degree of 3, because it has x to the power of 3. So our new dividend is not a lower power than the divisor, so we repeat all of the steps that we just made. So we get to do it all again. So we've got 4x to the power of 3 minus 2x squared minus 3x. Starting once again, we're going to resume from step 2. So this is another step 2. We divide the leading term of the new dividend divided by the leading term of the divisor. So we are going to have 4x to the power of 3 divided by 2x squared. So 4 divided by 2 is 2. And x to the power of 3 divided by x to the power of 2 would be x. So you're going to take that term and you're going to put it right next to the last term of the quotient above the house. Since it's a positive 2x, you just write plus 2x. If it were negative, you would write minus instead. But so we now have plus 2x. So we take that answer, we put it on the next term in the quotient. Now that you've done that, you're going to multiply that term by every term in the divisor and subtract the result. So let's go ahead, we're going to erase some things because we're going to write it all again. So we're going to erase the new dividend statement here. We're going to erase the highlighting that we have. I'm going to erase this part and this part because we're going to write it all over again. And this one, there we go. So we now have 2x. It's our new term in our quotient here. There we go. It's our new term in our quotient. We're going to take that value, multiply it to every term in the divisor. So we're going to take 2x and we're going to multiply each one of these terms. We can highlight this term now as well. So we're going to multiply, then we'll take our answer, and we're going to scooch down a little bit here, and then we're going to subtract the result from the new dividend, which I think I preemptively just erased that a little too early. We're going to leave that there, the new dividend. There we go. So we're going to subtract this new statement from our new dividend. So subtract the result. All right, now we need to know what the result is. So we're going to take 2x and multiply every term in the divisor. So 2x times 2x to the power of 2. 2 times 2 is 4. And x to the power of 1 times x to the power of 2 will be the same thing as x to the power of 1 plus 2, which is x to the power of 3. And those terms will cancel, which is what we wanted. It means that we're doing it right. All right, then we have 2x times negative x. So 2 times negative 1 is negative 2. And x to the power of 1 times x to the power of 1 makes it x to the power of 2. Then we have 2x times 2, which gives us plus 4x. All right, we're going to subtract the result now. We're going to scoot down just a little bit more here. We've got 4x to the power of 3 minus 4x to the power of 3, and those terms cancel. That's what we wanted. Then we have negative 2x squared minus negative 2x squared. So remember, since we have double negatives in this case, it's really like saying plus. So we have negative 2x squared plus 2x squared. Well, that's going to cancel out. That wasn't entirely the goal, but it's a very convenient consequence. We've canceled some extra terms out. That's great. That means one less time that we're going to have to do all of these steps over again. That means that what we have left, we have negative 3x minus 4x. So negative 3 minus 4 is going to be negative 7. And the x's get to stick along for the ride. So our final answer here would be negative 7x. That is almost our new dividend because remember, you're going to bring down that last term. So we brought down that plus 1. So now we have negative 7x plus 1. Now this is the new dividend. And it's really the new dividend, you know, part 2. There we go, because it's the second new dividend that we got. So now we want to check, is the degree of this new dividend less than the degree of the divisor? We said the degree of the divisor was 2 because it had x to the power of 2. And our new dividend has x to the power of 1. The degree of our new dividend is less than the degree of the divisor, which means we are done. This is now the remainder. So let's go ahead and write that. So actually, we're going to write this just a little bit over here. The degree of the new dividend is 1, which is less than the degree of the divisor. So it is now the remainder. So negative 7x plus 1 is r of x, or the remainder. That's what negative 7x plus 1 is. Then we have over here the 4x squared plus 2x. This whole statement here is q of x, or the quotient. So we now have all of the terms that we need to put into our division algorithms. We have p of x, d of x, q of x, and r of x. So we've done the math in this case. Now when we write our answer, we're going to write it in one of the two forms of the division algorithm, which, if we recall, we've got two forms of the division algorithm. This is going to be p of x divided by d of x is equal to q of x plus r of x divided by d of x. So our dividend divided by the divisor is equal to the quotient plus the remainder divided by the divisor. And that's the symbol for and. We also have p of x is equal to d of x times q of x plus r of x. So our dividend is equal to the divisor times the quotient plus the remainder. So that's how we're going to go ahead and put our answers into, that was my cat's tail. We're going to put our answers into the two forms of division algorithm. So the first one here, we're going to write in red, and the second one we'll write in blue. Just so we know the differences there. So our first one being written in red, we have our p of x, which we said was 8x to the power of 4 plus 6x squared minus 3x plus 1. So we'll start off by writing that. Divided by the divisor, which was 2x squared minus x plus 2. And this is going to be equal to our quotient 4x squared plus 2x. And then plus the remainder divided by the divisor, which the remainder was negative 7x plus 1, and the divisor was 2x squared minus x plus 2. So we write negative 7x plus 1 divided by 2x squared minus x plus 2. 2. There we go. So that is one form of the division algorithm. So that's one way to write your answer. And remember that if in your homework, if it wants you to put this answer, it would write p of x divided by d of x equals, and then the box where you actually put your answer. So that's the first form of the division algorithm. The second form of the division algorithm is going to be p of x is equal to d of x times q of x plus r of x. So we'll have p of x, which was 8x to the power of 4 plus 6x squared minus 3x plus 1 is equal to the divisor, and we're going to put these in parentheses, 2x squared minus x plus 2 times the quotient 4x squared plus 2x plus the remainder, which is up to you on whether or not you want to put those in parentheses or not. But it would be plus parentheses negative 7x plus 1. And that would be your answer for that second form of the division algorithm in that case. And once again, as a reminder in the homework, if it wants the second form of the division algorithm, it would write p of x equals in the box for your answer. It will literally say p of x or d of x. It won't actually have the equation that it used for the dividend or the divisor or anything. It would literally say p of x over d of x equals, or just p of x equals. And that would indicate which one that you would need to know. So All right, those were the two forms of the division algorithm. Color-coded each there so we know which is which. And you would write your answer in one of these forms. So, all right. That wraps up example 1 on how to use long division for polynomials. And that's how we would do that. So, all right, let's go ahead and go back to our lecture so we can move on and hopefully learn a much faster and quicker way on how to divide polynomials. All right, so we just finished up example 1, so moving on to a quicker and faster way of doing long division. So this is called synthetic division. So synthetic division is a quicker method of dividing polynomials, but this only works if the divisor is of the form x minus c. So x minus a number. This counts also for x plus a number. It's just that your value of c would then have to be negative because inherently it is set up as x minus that number. So if you had x plus that number, when you pull out c for synthetic division, it would end up being negative. You'll see that a little later. So, all right, in synthetic division, you're only writing the essential parts of long division. So you see that it ends up being a lot shorter. We kind of have simpler ways of working it out as well. So we have our long division problem here. So we had, 2x to the power of 3 minus 7x squared plus 0x plus 5 divided by x minus 3. So here was our full long division. We found the quotient, divided the leading terms, multiplied that term into our divisor, subtracted that result, did it again and again until we ended up with a quotient and a remainder. So quite a bit long. We just saw from our last example how long this could really take. And here's synthetic division. So, I mean, even just visually, it's a lot shorter. There's a lot less writing, and it's just a lot less. So what we saw here was that you take that value of c. So if you have x minus a number, you would take that number and write it outside the house. The house is pretty much the same, except it gets flipped upside down, so you now have an upside down house. But you would take that value of c, write it outside your upside down house, and you would take the coefficient of every term of the dividend, and you would write that out inside the house. So you're dropping those x to the powers of some numbers. You're dropping all of those terms, and you just have the coefficients. And then we'll see in the next slide how this is calculated. But it ends up being a lot shorter, a lot easier, a lot cleaner. But once again, this only works if you have a divisor that looks like x plus or minus a number. If it's anything more difficult than that, you can't use it. You would have to use polynomial long division. But if you are allowed, or if you're given a problem like this, it just makes it that much faster. So, all right, let's see the steps on how to do synthetic division. So, our first step would be to set up synthetic division. That is usually the first step in all of these types of problems, is to just set it up. So to set up, you'd write out all of your coefficients of your dividend in descending power order. So if it's not already in descending power order, you would rewrite it to be that way. So this would be, x to the power of 3, x to the power of 2, x to the power of 1, x to the power of 0. It's descending exponents. Then you make sure to include a coefficient of 0 if you have any missing terms. So any missing terms that you have, you fill in a 0 for that term, just like last time. Then you would draw a horizontal line underneath all of those terms. You're drawing the upside down house, and then the vertical line before the first coefficient on the left. Then write the value of c. So remember, the divisor is x minus c. So you're going to take that value of c and write it in front of that vertical line there, front or outside of the house. So this is where that, that idea comes from, that if you had, say, x plus 3, that's really the same thing as x minus negative 3. The format, the base kind of home format, is x minus that number. So if you have x plus that number is negative. So if you had x plus 3, you would have a negative 3 on the outside of the house instead of a positive 3. So it's the opposite sign that's in front of it. Then you'll write your value of C on the other side of the vertical line to the left, and it would look something like this. So we see 3, vertical line, horizontal line, so we have 3, then the house, 2, -7, 0, and 5. And this represents the divisor being x minus 3, and the dividend being 2x to the power of 3 minus 7x squared plus 0x plus 5. So this is what it would end up looking like. Step 2, you would bring down the leading coefficient to the bottom row. So it was kind of skipped over here, but typically you would have this statement written out. You would draw another horizontal line below it there. So you'll see that in our example, when we draw out everything from step 1, we'll draw another horizontal line with a little bit of space in between what we had already written. So that creates kind of a top row where you have your dividend and your divisor written, and then you have this middle row, and then you have a bottom row separated by another horizontal line. So you'll see that again when we do an example. But so you would bring your leading coefficient to the bottom row. So skipping that middle row, bring it straight to the bottom, and you would just recopy it. So you just take it down, recopy that number. Then step 3, you would multiply C by that value was just written in the bottom row. You would take that result, so you have C times the number in the bottom row, and whatever that result is, you would write that in the middle row beneath the next term from the dividend. So you would write it beneath the next coefficient in order to be divided. Then you would add that column. So you created a column in step 3. You had the term from the dividend plus the result of the first term of the dividend times C. So you add the column and you get a new number in the bottom row. And you repeat all of those steps until you are finished. So that is synthetic division. Once again, a lot of words, a lot of just kind of verbally saying how we're going to do this, but let's go ahead and actually do it. So we're going to go ahead and go on to our next example, example 2. We're going to divide 3x to the power of 3 minus 5x squared plus 7 by x minus 2 using synthetic division. So let's go ahead and go over to our notes to work out this problem. All right, so here we have problem 2. We are dividing 3x to the power of 3 minus 5x squared plus 7 by x minus 2. So before we set anything up, let's go ahead, just kind of establish a few things. We want to figure out, are we missing any terms? And what is the value of C? So if we look to our dividend here, this is P of x, the dividend, and it is also missing a term. We are missing the x to the power of 1 term. So we're missing that x to the power of 1 term, which means we're going to fill it in with a 0. So this means our dividend is really 3x to the power of 3 minus 5x squared plus 0x plus 7. So we fill in that missing term. Then we have our divisor, or d of x. We want to know what the value of C is. We said that our divisor would have to look like x minus C. So in our cases, we have x minus 2. C is equal to 2. Now, another really quick way to find out what C is equal to is that you could take the divisor, set it equal to 0, and whatever that value x equals is the value of C. So that's another way that you could do this. So we could take x minus 2, set it equal to 0. I'm going to erase that little parentheses right there. Then we can say, we can add 2 to both sides. This means that x is equal to 2. That means that C is 2. So this is just another way that you could find that value of C. If it feels confusing to think of like x minus a number, and if it's plus, it's the opposite. So we would see in something like this, if we had x plus 2, we would subtract 2 from both sides. X would be negative 2. That means that C would be negative 2. So that's just another way you could find C. So another way to find C is that. So, all right, so we know what C is. We filled in our missing term. So let's go ahead and set our problem up. So we're going to write our value of C, which is 2. And then we draw our upside down house. Say our upside down house. We're going to write in the coefficients of our dividend. So we have x to the power of 3. The coefficient is 3. So we're going to write 3 first. Then the coefficient of x squared is -5. We see those signs are going to go along with the coefficient. So minus 5x squared, that's really -5. So we have -5, leave a little bit of room between the values. Then we have 0 because we had 0x. And then we have 7 at the end. So 7 goes in there at the end. I'm actually going to put the 0 in red. So we remember that it is a missing term. All right. Now I'm going to scoot this up a little bit. We're not writing anything above this, so it doesn't have to be, you don't have to have like a last space above or anything. Then we're going to draw this horizontal line right here. So this creates a middle row and a bottom row. All right. So we have a middle row, a bottom row. We have all of these terms, so we can go ahead and start. So step 2 is that once you have your setup, you will take the very first term and just copy it to the bottom row. So we can just draw an arrow going straight down. And you write that same number below. You just copy it. Once you've done that, step 3 would be that you would take your value of C and multiply it by that value in the bottom row. So we're going to multiply. Then you're going to write your results in the middle row. So your result goes up. So 2 times 3 is 6. And that result goes in the middle row. And you are going to add the column. So you're going to add straight down. So -5 plus 6 comes out to a positive 1. You write that new value in the bottom row, and everything repeats. So we're going to have 2 times 1, and that result goes in the middle row. 2 times 1 is 2, and you're going to add the column. So 0 plus 2 is 2. And we repeat. We multiply the value of C by that new value in the bottom row. You write your results in the middle row. 2 times 2 is 4. And you add the column. 7 plus 4 is 11. And there's no more terms, which means that we're done. So, all right, we're done. But now we have to interpret what our answer means. So we're going to go ahead and do that. We had our middle row, we had our bottom row, we had all of these steps here. I'm going to erase these terms so that we can, well, we don't necessarily have to erase. I will leave them for now. But we need to interpret what our answer is. So to interpret our answer, you're going to go from right to left on the bottom row. The number that's all the way to the right is your remainder. So this term right here is the remainder. So the one that's all the way to the right is the remainder term. So you're going to go from the right to the left. So it's a little bit opposite because we always say, a lot of the time we're always going from left to right, but in this one case, we're going to go from right to left. So starting with that remainder term, one term to the left is going to be an x to the power of 0. It's always x to the power of 0 first. We know that x to the power of 0 is really just 1. So that 2 is really just going to be the constant term. But it's always good to start with 0 because that'll help us keep count. So that last term is the remainder. The one to the left is x to the power of 2. And you are going to add an exponent each time. So x to the power of 0, one more to the left would be x to the power of 1. And one more to the left would be x to the power of 2. So last term is the remainder, and every step to the left, you get a +1 on the exponent. And then we just add all of those terms. Or subtract. If it's negative, it would be subtraction. If it's not, then it is addition. So plus, and then we have our remainder. So this term right here, this whole chunk is the quotient part. And remember, this is q of x and r of x. So we had q of x and r of x. We started out our problem with, oh, that was the last one. We started out our problem with p of x and d of x, the dividend and the divisor. We now have a quotient and a remainder. We're going to go ahead and write this in the two forms of the division algorithm. Just because that is the format that it will almost always have you write, although it will occasionally just ask you for the quotient and the remainder. You will just enter those separately. But we're just going to go ahead, we're going to practice, putting it in the two forms of the division algorithm. So we're going to scoot our problem down a little bit, two forms of the division algorithm. As a reminder, these are p of x divided by d of x is equal to the quotient plus the remainder divided by the divisor. And it is the dividend is equal to the divisor times the quotient plus the remainder. So once again, we're going to color code these so we know which one we're talking about here. So the first one is going to be the more fractional form one. So we are going to have our dividend, which was 3x to the power of 3 minus 5x squared plus 7 over x minus 2. Is equal to the quotient, which is the first 3 terms in our case. It's every term except the one all the way to the right. So it's 3x squared plus x plus 2, because x to the power of 1 is really just x. 1x we can just say is x. And x to the power of 0 is technically just 1 times 2 is just 2. So the quotient is 3x squared plus x plus 2. That's our quotient. And then plus the remainder, which our remainder was 11. So we're going to have plus 11 divided by the divisor, x minus 2. And there we go. That would be one of the ways we would write our answer. Now, the other way we're going to write our answer is with the other form of the division algorithm. So we have our dividend, 3x to the power of 3 minus 5x squared plus 7 is equal to the divisor, x minus 2, times the quotient, 3x squared plus x plus 2, plus the remainder, which was 11. And that would be our other answer, the other way that we would write that in the form of the division algorithm. So that problem, quite a bit shorter, quite a bit cleaner. The only part that gets confusing is really just that one at the end, that you have to interpret your answer a little bit more. It's not quite as clear cut, but that is the one, kind of fuzzier part that you would have to do, that interpreting part. But the rest of it, may feel a little less confusing to you, or maybe not. Maybe you really like long division, and that's perfectly okay. So remember, whenever it comes to problems where your divisor is x plus or minus some number, you can use either way. You can use synthetic division or regular long division. But if your divisor is anything more complicated than x plus or minus a number, you would have to use long division. But if you really like long division all the time, you can definitely use long division all of the time. But if you're like, I really like synthetic division for these kind of easier divisors, then by all means, you can use synthetic division instead on these easier problems. So, all right, as a reminder, those were our answers there. And we're going to go ahead and go back to our lecture to continue on with the section. All right, so that was example 2. Moving on, we have some final theorems of our section that are going to kind of help us out on a few specific types of problems. So we have the remainder and the factor theorems. The remainder theorem says that if the polynomial p of x is divided by x minus c, so something that you can use the synthetic division on, then the remainder is the value of p of c. So if the question is that you just need to find a remainder and the divisor is something that looks like x minus c, you would take that number, plug it into your polynomial, and the answer will be the remainder. So as an example here, we have p of x is equal to 3x to the power of 5 plus 5x to the power of 4 minus 4x to the power of 3 plus 7x plus 3. Very long. And we're going to say we're going to divide this by x plus 2. The remainder in this case would be 5. So we would get this value of 5 by plugging in -2 into this equation for p of x. So first off, identifying that c would have to be a negative number, we would have x plus 2 is really x minus -c, so c would have to be -2. You'd plug a -2 into your polynomial, and the answer would end up being 5 if we calculated this out. So for a problem like the remainder theorem, there is a problem on your homework, and you may, end up seeing it. And it is some ridiculous looking problem. It's got, exponents of like the hundreds, very high numbered exponents. The idea, and then it asks you for the remainder. The idea is that that value of c is going to be 1 or -1. You would plug that value into the equation and the answer would be the remainder. So it can give you some kind of crazy problems like that. And your answer would end up being this kind of plain number that you would get by just plugging in the value of c into the equation. You don't have to actually do any like long division or synthetic division, or anything like that, because it would be crazy. It would be some crazy problem. But all right, so the second theorem we have is the factor theorem. So if we say that c is a 0, and this is, we say c is a 0 if or of the polynomial if and only if x minus c is a factor of p of x. So we are introducing this new term, which we're calling a 0. So we say that x minus c would be a factor, meaning that your polynomial could be broken up into these kind of even whole chunks called factors. And we've done things before with factoring and things like that. So it's a factor. So x minus c would be a factor if you plug c into the polynomial and it spits out 0. So you would use the remainder theorem. You would have some value of c. You use the remainder theorem to plug it into the polynomial, and the remainder is 0. That means that we call c a 0, because it means that when we plug in this value into our polynomial, the result is 0. That also means that x minus c is a factor of the polynomial. It's an even factor. So an example, p of x is equal to x to the power of 3 minus 7x plus 6. And p of 1 equals 0. 1 to the power of 3 is 3, minus 7 times 1, so 1 minus 7 is negative 6, plus 6 is 0. So by plugging in the number 1, we get an answer of 0. This means that x minus 1 is a factor of p of x. Then, once we know this statement, we can find all of the other factors of p of x using synthetic or long division. If you did that, you would get that p of x was really equal to x minus 1 times x squared plus x minus 6, which that statement you could factor using any factoring method that you know of. Backwards foiling, there's like, square method, triangle method, all that kind of stuff. And you would get that p of x is really equal to x minus 1 times x minus 2 times x plus 3. So p of x was made up of 3 different factors. So that's one way that we can kind of factor a polynomial, finding one factor and using division to find the rest. So, all right, let's see how this is used in an example. Example 3. We want to find a polynomial of degree 4 that has zeros, -3, 0, 1, and 5, and the coefficient of x cubed is -6. So we're going to have to find a polynomial. That means that we are creating a polynomial with the given information. It has to be of degree 4, which means the highest exponent on x has to be 4. It has the zeros, -3, 0, 1, and 5, and the number in front of the coefficient of x to the power of 3 has to be -6. So we've got 4 requirements. So we need to come up with a polynomial that meets all of these 4 requirements, and we're going to do it by starting off using the factor theorem. If we know that we have the zeros, -3, 0, 1, and 5, that means that x minus -3 times x minus 0 times x minus 1 times x minus 5 creates the polynomial. And then all we have to do is fiddle around with some things to make sure all the other requirements are met. So let's go ahead and go to our notes and work this problem out together. All right, so problem 3, we have our 4 requirements. We need to create a polynomial. That polynomial needs to be degree 4. It needs to have zeros, -3, 0, 1, and 5, and the coefficient of x cubed has to be -6. So we're creating a polynomial with all of these things. One thing that is important to note is that we have the zeros, -3, 0, 1, and 5. These are each going to be values of c. We could say this is c sub 1, c sub 2, c sub 3, and c sub 4. If something is a 0, it means that x minus that number is a factor. So p of x is equal to each one of these values of c in factor form, multiplied together. So if -3 is a 0, which we called it c sub 1, then x minus -3 is a factor. So the way that we're going to write this out is that our polynomial is equal to all of these factors multiplied together. So x minus c sub 1 times x minus c sub 2 times x minus c sub 3 times x minus c sub 4. And this would be for the number of values of c that you have, or the number of zeros that you have. So c sub 1 we said was -3. So we're going to take this step by step. So we got x minus -3. That was c sub 1. Then we have times x minus c sub 2, which was 0. And then we have x minus c sub 3, which was 1. And lastly, c sub 4 we said was 5. This would be x minus 5. We got these statements here by saying that, c sub 1 was -3, and that c sub 2 was 0, and c sub 3 was 1, and c sub 4 was 5. So that's how we created this new polynomial. P of x is equal to x minus -3 times x minus 0 times x minus 1 times x minus 5. So let's go ahead and just simplify that just a little bit. We're going to simplify the double negatives, and the x minus 0 is really just x. So P of x is equal to x times x plus 3 times x minus 1 times x minus 5. And we're going to multiply these all together. Now, something like this is going to require quite a bit of foiling, or, the square method, triangle method, circle method, whatever method that to multiply factors together. So in our case, let's go ahead and just kind of separate it into two. Let's go ahead and take this result and multiply by this result. And we're going to move down a little bit here. So starting with, and we're going to make the second one actually, we're going to make this blue instead. So starting with x times x plus 3, we can just distribute the x inside of those terms. Don't have to do anything crazy. We're not really multiplying anything like how the second group is going to be. We distribute the x inside, and this way we're going to get x squared plus 3x. We just distributed that x inside. So that was that result. And it's going to be a little bit more difficult with the second one. So we really have to FOIL on the second group more. So foiling, we're going to have first, which x times x is x squared, times outer, so the outer terms, x times -5 would be -5x, multiplied by the inner terms, -1 times x would be -x, times last, so the last terms, -1 times -5 would be +5. Then we can simplify this a little bit, -5x minus x, it's going to be -6x. So we can simplify that a bit there. We can say x squared minus 6x plus 5. And that was that term there. You can multiply these in any order or way that you'd like. This is just one way that I like to do it. I like to kind of break it up into two groups and then multiply those results. But you could definitely go one at a time instead. All right, so now since we have these results, we need to FOIL again. So we're going to do this again. And now it's not quite foiling as much anymore because we have more than just two terms in each factor. So it's going to work a little bit more like a very large distributive property type of multiplication here. So what we're going to do is we're going to multiply, once again, still the first terms, so x squared times x squared, which will give us x to the power of 4. And then we're going to take that first term and still multiply it by now the middle term. So x squared times -6x is going to be -6x cubed. And then multiply the first term by the last term. So x squared times 5. It's going to be +5x squared. Then we're going to take the second term of the first factor and do the same thing. So we're going to take 3x times x squared. That would be plus 3x cubed. 3x times -6x. That's going to be -18x squared. And 3x times 5 is going to be plus 15. So we multiplied our two factors out again. Now we have this polynomial here, and now we just want to simplify. We see that negative 6x to the power of 3 and 3x to the power of 3, we can combine, those are like terms. 5x squared and negative 18x squared are also like terms, so we're going to combine our like terms. And the other terms are just going to stay on the outside. So simplifying our polynomial, we begin with the highest numbered exponent there, so x to the power of 4. Then we have negative 6x cubed plus 3x cubed. That's going to simplify to a negative 3x to the power of 3. Then we have 5x squared minus 18x squared. That's going to leave us with a minus 13x squared there. And then our last term is plus 15. So, all right, what we have right here is a polynomial of degree 4 that has the zeros negative 3, 0, 1, and 5. So this right here, p of x of degree 4 with the zeros negative 3, 0, 1, and 5. So on our requirements, we have satisfied the first three statements. So we saw the highest numbered exponent was 4, which means it was degree 4. When we set up our factors, we included those zeros, so that's how we know it has those zeros, and we created the polynomial in general. So that was the first three requirements. Now the last requirement is that we want the coefficient of x cubed to be negative 6. And as it stands right now, the coefficient x cubed is negative 3. Well, we want it to be negative 6. If we want it to be negative 6, but it is negative 3 instead, then all we'd have to do is just multiply by 2. And if we go with that idea, we just need to multiply everything by 2. So if we multiply the whole polynomial by 2, we will achieve this goal of having the coefficient of x cubed be negative 6. So that's what we're going to have to do. So the coefficient of x cubed is negative 3. We want it to be negative 6. So we'll multiply all of p of x by 2 to make this happen. So scoot a little bit down more here. So we've got p of x is equal to 2 times x to the power of 4 minus 3x cubed minus 13x squared plus 15. Now we're going to distribute this 2 to every term inside. And we'll get p of x is equal to 2 times x to the power of 4 minus 6x cubed minus 26x squared plus 30. And that polynomial right there is a polynomial of degree 4 with zeros negative 3, 0, 1, and 5, and has a coefficient of negative 6 for x to the power of 3. So we had both of those things together. That crosses off our last requirement there, which means that we achieved all the requirements that we wanted for this polynomial, and we created our final polynomial here with all those requirements. And we did all of this mostly using the factor theorem with some, a little bit of manipulation and things like that. So, all right, that's how we did example 3. Let's go ahead and go back to our lecture to finish up. All right, so that was example 3, and that wraps up section 3.3. So in summary, in section 3.3, we covered long division of polynomials, synthetic division, the remainder, and factor theorems. So, all right, that's the end of our section here, and I'll see you again in the next one.